doing the thermal test in the way we do. We're not going to go over every single detail again today, just to sort of save some time since you've probably already seen it. So this is the Xbox Series X. Obviously, it is not too dissimilar from the NZXT H1, except in our experience, this one doesn't catch on fire. The top of it is exhaust. Intake comes in primarily from back here, but only about half of each of these vents is used, a quarter of one of them. And then there's a little bit of intake on the bottom. Unfortunately, no holes in that part. So if you take off the base plate that it stands on when vertical, you're not actually exposing any additional air intake pathways if you were to use this horizontally. And speaking of, we'll be doing testing horizontally and vertically. Easy enough. This is all done in open air in a highly controlled ambient temperature environment. So we're at about 21 degrees Celsius, plus or minus 1 degree for all of the testing. And horizontal versus vertical in open air should show no difference. There are a couple of really important things to discuss before showing the numbers. So these are not 100% comparable to the PlayStation 5 numbers. That is sort of by design. It's a consequence of the testing setup. Because we don't have a way to measure the on-die sensors like we do with computers, with PCs, or anything that you have some control over the software, we have to use external probes. External probes are extremely accurate. Their precision's pretty good. But the problem is you can't place them in 100% the same way on the two different devices because they're built differently. They have things in different places. They have different cooling solutions. They have memory and MOSFETs and inductors on different sides of the PCB. Everything's different. So they're not 100% comparable. What is useful is getting an absolute number out of the end of it where you can make a determination as to whether this particular box is overheating, running hot, running well, whatever. But for comparing the two devices to each other, we have a little bit of insight for the SoC temperatures one versus the other. But they're different SoCs. They have different CU configurations, for example. They have different frequencies, so they will run differently. The thermals will be different by nature of the hardware being different, but we can still get a general idea of how the two devices perform relative to each other. We would just strongly advise that you don't draw direct comparisons, and there's a reason we haven't put all the numbers in the same chart between the Xbox and the PS5. It's because although you can get a good idea for how things perform, they're not 100% linearly comparable by nature of the testing process. And that's fine. We just want to make sure everyone's really clear on that. Overall, though, we're doing testing with the same tools and in much the same way. So it gives you a good idea. Typically, we find about 23-ish, 25 minutes is sufficient for most CPU coolers and GPUs in most scenarios, except for a few of the larger liquid coolers with the heat capacity is just so much higher. With the console, though, we found that the components take so long to heat up in this, just by nature of being a small box where they're really trying to control noise levels, that running for a full hour was what we needed to just make sure we definitely hit steady state and held it for averaging. There are a couple of wiring considerations for thermocouples. Not going to go through every single one of them on camera here today. For the placement of the thermocouples, we use a few different types. They are all K-type in the literal sense, and they're all calibrated. So we do an ice bath and a boiling water bath, which allows us to calibrate the delta from one thermocouple to the next and get them all aligned in the same way on the charts. For ambient readings, we take that actively every single second of the test, and we use that to ensure that the ambient environment is controlled, which it was for all of these that are being presented today. It's about plus or minus 1 degree Celsius for ambient, which does influence everything, because if you run higher ambient temperature, well, the box will obviously behave in a nonlinear fashion because you might have the fan ramp up, for example, and that could change the behaviors. As for when I said there's a few different types, so we have some of these thermocouples that are actually really expensive thin wire thermocouples that have a polyamide adhesive on them. It's a polyamide pad, and that's placed for mostly memory component measurements, which we've shown those in GPU tests in the past too. We have one thermocouple that is sandwiched between the MLCCs on the back of the SoC. It's on the back side of the board. That means we're kind of close to the flip chip BGA package, except you've still got a layer in between there. It's not a perfect measurement, but that's the nature, not being able to read the software because they don't make it available to you. And then we also have a thermocouple on one of the MOSFETs that we believe to be one of the potentially hotter MOSFETs because of its location, where typically a MOSFET that's between, for example, a whole bunch of other MOSFETs in the VRM. So if it's in the middle, as long as there's not like a fan directly above it or something, which that's more of a GPU thing, then it should be pretty hot. It should be about the hottest they get. It's also next to the inductors, so you've got a FET that's between all the other FETs and the inductors. There you go.
start.